any questions you would like to ask from the MCQs? One more question. How is information stored in the memory? Let me see if I can pull the question paper one more time. Bits now, everything is in bits. Everything is in bits. Hexadecimal is just for our understanding. It's easy to, if you have a sequence of zeros and ones, it's hard to make out what it is. So hexadecimal helps understand. Between how many students are in the class? I usually get 119, 120 attendance. How to print the address of a variable? We have seen in the, check the videos, we have seen how to print. Yeah, we have seen, right? That's the, remember the program where we tried to crash? Yeah, we can have a program that can. The program which CPU hog program, yeah. Okay, now I finally got it. So let's see, I will share the screen with you, sorry. You're able to see the screen? Okay. Let's discuss the questions. Select all hardware components required to execute a program. CPU, RAM, keyboard, display. What are all the components? CPU and RAM. Do you need a keyboard? You don't need a keyboard. Like for example, when you're using keyboard is one particular IO device, but it's not necessary. Like on your mobile phone, when you open WhatsApp or some other thing, so we can, and then also, you know, like you can give voice commands to Alexa. Voice, yeah. So there are many ways of giving input. So you don't need a keyboard. How about display? You don't even need a display. Like think of a robot which is moving. Data centers, yeah, of course. Amazon Echo. You can use a printer. Yeah, that's what happens, right? So on your when you swipe your credit card. Okay, anyone fell for this question? That's why this is a tricky question. People, keyboard. Okay. Sorry, I am laughing. Without every, so the instructions of a program should be available in the RAM. Should be available in the RAM. CPU talks, communicates with the main memory, RAM, to load the instructions and execute. This is the discussion in the first lecture of this course. Select all the, what if someone marks ABCD? Yep, 0. Select all the correct answers from the below. A pointer contains the address of a variable in the memory. How about this? A pointer contains the address of a variable, right? No, huh? That's what it is, na? A pointer contains the address of a variable. A pointer contains the address of a variable on the hard disk. Yeah, so on the hard disk, it doesn't, the variable is not even allocated memory on the hard disk. An array variable contains the base address of the array. Yes, memory is allocated to a 2D array row by row consecutively. We discussed this in the class. At least this question all of you should have done. No? I hope all of you did it, this one. Select all the correct statements. Math.h contains the code for all the math libraries. Now, we discussed this at length, right? It only contains the signature. Header only, yes. It contains. Hash define statement declares a new variable. Yes or no? No. No, hash define doesn't declare a new variable. The return type of printf is void. No, why is it? It's not wrong. No, it's not. We have to select the correct statement. Yeah. The binary representation of 2 and 2.0 is the same. Yes or no? No, 2 is represented in a certain format and 2.0, it is represented in a floating point representation. They have different representations. Any line in your C program which starts with is pre-processed by the last one is right. Both statement is false. We have looked at Yadath in one of the lectures. We have seen quite a bit that math.h only contains the signature. What is the function signature? What are the types of the parameters and what is the return type? Okay. And the actual math, the actual, like for example, what is that function we used? We used one function where we have to link it with the square root. So we checked, right? Don't you remember in math.h, we went to the math.h header file. We saw that it only contains the signature and the actual code is present. The actual instructions associated with square root and other functions in the math library, they are present in a different library. Do you remember that discussion? We discussed quite a bit on this. We looked at the code also, we looked at math.h also, and we said, hey, you know what, here you are just finding the declaration, the signature, but not the actual code. Same with printf also, yes. Yes, if you go look at stdio.h, we looked at printf also actually. We, if I remember, but maybe not square root, definitely we looked at the math.h. So what does printf returns the number of characters? No, stdio.h doesn't contain the code. It only contains the signature of printf and scanf. What is the signature? The type of the parameters to the function and the return type of the function. That is the signature. Okay, so define hash define statement, and the fourth we will see. Select all the correct options. I will explain. So I'm making a note. We have to look at hash define, the return type of printf. These two we would like to see. The instructions of a program are stored in the memory in hexadecimal format. No, everything is bits. The data of a program was stored in main memory in the hexadecimal format. Again, false. The instructions of a program are stored on the hard disk using bits. Yes. It is possible for a program to run forever without halting. CPU hog.c. An array is being passed as a parameter to a function. Pick the correct option from below. The whole array will be copied to the local memory of the function. Only the base address of the array will be passed. No, but the size is only passed optionally, okay? Only the base address. Since the call by value parameter passing by any changes to the array elements will not be reflected in the original array, false because we are working with addresses. So only B is right. Question 5 is very, very deep. If you understand question 5, then that means, you are good. We are never using call by reference. See only call by value. How many of you got it all 5 questions right? Four is good. Nice. Very nice. Yeah, 5, 3. Even 3 is good, 2 good, 1. You have to work hard. Okay. Okay, so now question 4, option 3, what is that? The instructions of a program are stored on the hard disk using bits. It's true. It is possible for a program to run forever. No partial marking, guys. It's again, no, you have to give negative marking, and in order to have meaningful partial marking, you need to have negative marking. And when you give negative marking, some students get into trouble, and it's all okay. Don't worry, couple of marks. Don't worry. 2 marks. Instructions are present in. If I do AB and correct is ABC, then it is 0. Huh? Yeah. Hey, don't worry, guys. You're spending a lot of energy on this thing. No full retest. Okay, so now we will solve 2 problems, Pythagorean triplets problem and the prime number problem. There are these questions. What is hash define statement declares a new variable? What is the thing about variable? Will variable have a memory? Is allocated memory, yes or no? And what happens, in one of the programs, what we did, so we did hash define pi something. There is pi allocated any memory? What happens to pi? What happens to pi? It is replaced with the value it is defined. So it's not a variable. Preprocessor replaces pi. So it's not a variable, very simple. Macro definition. So that's all. So it's very simple. Okay. So now let me do one thing. First part of question 5. The whole array will be copied to the local memory of the function. So Shivai, the last class I would like you to review. Do you agree that we discussed this in detail in the last class? That the base address of the array is copied into the parameter, only the base address is copied, nothing else. But once we have access to that base address, then the whole array can be manipulated. In the last class, I don't mind, No, there is nothing like where are the values getting copied, Shwai? It's just the base address of the array is getting copied. So the lecture before the quiz, the review lecture before the quiz, please watch it. Okay. In that all the time in C programming language, it is called by value. That's it. When you pass a pointer, is it called by value or is it called by reference? You're just passing the address. It's just called by value. All the time it is called by value. Okay, so now let's again, so everything, so all the questions except for printf, they are discussed in the class. Okay, I didn't give anything, I didn't give anything where no, you have to read the textbook also. Okay, everything is discussed in the class. Only the printf statement I didn't discuss. No? So and that I gave because I wanted to check if you are reading the textbook or not because it's very important. So what is the question? No, read both. No, it's not CP reads both king and essential printf.c. How to write punching machines, how to write code without keyboard 20 years ago. Hey, it was there. No, actually in the King book it is given in much more detail than Essential Cs. Okay. Okay, so printf. So let's see, what do you think will be the output? It prints the number of characters that are printed. No, it will be Yeah, there are 70 characters in this. Yeah, that is counted as one character. /n is counted as one character, including spaces and all. Okay. Yeah, that's all. So similarly, scanf has a written value. The homework for you is figure out what is the output of what is the written value of scanf, and in fact that is useful. The written value of scanf is used in quite a few cases. The written value of scanf, whereas usually I didn't see printf value being used anywhere. No, not like that. No, it's every not. We are make printf is a function call, and a function can have a written value or not. Are you all with me here? Okay. So now let's solve the prime numbers problem. So if you solved, if you did homework 1, assignment 1, then I feel you should be able to kind of solve the prime numbers problem. So let's see what is the strategy for prime number thing. So if you keep C things aside, so you read n and then you check. So if n is prime, then so you have to check for all. This is for all symbol for all. Let me do one thing. So if you look at any number, I am just using a very simple approach. Okay, if you pick any integer between 2 and n minus 1, what do you get? So this is in math, this is divisible, and this is I doesn't divide. Let me make it, I doesn't divide. Or I is not a factor. Or let me do one thing. Or I can say in C partially, you take n. You heard I should not be a factor of n. If I is not a factor of n, what is the remainder when I is not a factor of n? Then when we take the remainder when we divide by n, so this is not equal to 0. That's all, no? That's it. So this is a condition that we have to check, and in order to do step 2, we have to write a loop. Okay, we have to write a loop. So what do we do? Int n, maybe capital N, printf, enter n. There is one more interesting input given by one of in the feedback form by one of your friends. I'll talk about it in a while. I appreciate all that. If n%i, if it is not equal to 0, so what should we do if n%? We should break. We should break from the loop. No, it should not break from the loop. No, it doesn't tell us anything. Actually, we should do this. We keep checking. If you, we initially think that we will have a variable is underscore prime. We initially think it is a prime. Okay, we initially think it is a prime. And if you find an evidence against it, we will change our mind. Yes or no? Does this work? We initially think that it is a prime. And if we find a factor, if we found a factor, then we change our mind. That's all. So that's the basic logic. And then finally, what do? We check if is underscore prime. So printf So in this program, is this necessary to stop? Even if you find a factor, we are just continuing the story. Okay. Format document. Does this work? Okay. For 1 and 2, yeah, for 1 and 2, you have to check. Okay, separately. I'm not, yeah, make a separate special case. Yeah, maybe we can do if n is equal to 1, what we can do is printf. Is this true? 1 is neither prime. Now composite. And then how we should do? We will put an exit statement here. So we exit from the program. And then if n is equal to 2, then we will say 2 is a prime. There is no need for making separate special case. Okay, at least for 1 we need, na? No need for 2, right? Yeah, I think no needs. There is no need for 2. Yeah. Okay. But I want you to look for this exit 0. You check for positive numbers and all. So I'm just making my life easy by not taking care of all those cases. GCC prime.c. In order to use hash include std lib. So in order to, so you know when you do exit, no, you are you exit from the program. Okay, you exit from the program. Oh, I didn't have a scanner here. So 4 is not a prime, 2 is prime, 7 is prime. We can use return instead of exit also, it will work. Yeah, so here we can use instead of exit 0, we can even have a return statement. This will work. Yeah, but still, try 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, let's not see that number, Bhargav, that number doesn't fit into n. Doesn't fit into an integer, it's too big. Okay. Yeah, that return is targeted for main. So I used stdlib because when on line number 15, I used an exit statement. There are boundary cases and all, but did you get the logic? What is the logic? I want to check on this. I want you, are you all with me on the logic? Okay, the logic is you think that it is a prime number to start with. And then if you find an evidence against it, you change your mind. It's okay, you can use any logic. This is one logic. Everyone with me on this program? Okay. So a couple of things here. Once you find that a number is not a prime, you don't need to waste computation by continuing, right? Yes or no? Once you find a factor, that's it, right? You should stop. There are two ways of doing it. One way of doing it is you say we can use go to L1, where L1 this is. Okay, on line number 25, we are using a go to statement. That is, you are going out of the loop. This is one way of doing it. Okay, are you with me? By using the go to statement, we save on computations. The other way of doing it is you don't use go to, but use break statement. When you use break statement, what happens is break finds the enclosing while loop. The enclosing loop is for loop. So we come out of the for statement. Okay. Are you all with me here? That the break statement, it will break from the loop. It will break from the loop, from the enclosing loop. The enclosing loop is the for loop on line number 20. You will come out of that loop. This reduces the time taken for the program to execute. Once we find the evidence that there is no impact on the memory used, it will have an impact on the time taken by the program to execute. Imagine running a program on a very large even number. So at the beginning itself, you know that it's an even number, it's divisible by 2 and you should stop. But without this condition, you keep on going, doing unnecessary computation. Now shall we solve the next problem, Pythagorean triplets? So okay, so now in this problem, yeah, let me save some typing. So we are reading n. We want to print the first n Pythagorean triplets. So what is the idea here? So the idea here is, think of a computation tree. No, this is a, so let's call it as that the node as. So first what we will do is we check if one is a Pythagorean triplet, and we then check, so not one. We try different hypotenuses and we see if we initially think of, let's say we keep looping from, you keep looping, and what we want to do is we want to check if I is a check, if if I is a hypotenuse of a Pythagorean triplet. And we want to print the first n Pythagorean triplets. So initially the number of Pythagorean triplets that we have, what will be the initial count of Pythagorean triplets? We didn't, when we start the program, we didn't see anything, right? So we start with the initial count as 0. I hope you are all with me that we didn't see any triplets so far. So we want to keep the initial count is 0, and we would like to continue. We want to continue until we find the number of triplets equal to until the number of triplets is equal to n. We would like to continue. Are you with me here? We want to until while less than or equal to n, we will continue. Look at the number of triplets, okay? And then we use a variable, so hypotenuse. H is a potential hypotenuse. We start with h is equal to 1, okay? H we should not have less than or equal to. Once it is equal to n, we should go out. Okay, so we'll have h is a potential hypotenuse, int h. I'm using a very dumb method. We are using a very dumb method, but that's okay. Okay, if h is a hypotenuse, then what happens? Then we will have, if h is hypotenuse means, what do we get? We need to have something like, we need to have one side s1 square plus s2 square is equal to h square. Okay, there are many ways of doing it, but I'm telling you, we are doing a very dumb way of doing it. Okay, and what is the range of s1 and s2? What is the range of S1 and S2? What are the potential values for S1 and S2? I am taking much more easier bound. Okay, so again I'm telling you, we are using super simple. We know for sure that the sides of the two triangles are less than the hypotenuse. Okay, the sides of two triangles are less than hypotenuse. So what we are doing is, we are trying for side S1 is equal to 1, S1 less than H, and S1 plus plus, and just copy the same. Okay, anyway, I will write here for int S2 is equal to 1, S2 less than H, S2 plus plus. Does this make sense? We are all good so far. And what do we need to check? If S1 star S1 plus S2 star S2 is equal to H star H. And we need to be careful here because we don't know whether the precedence okay, so we can yeah, there are optimizations we can do, we will do in a while. Does this make sense? Are we good? We can remove while loop. Huh? I don't know how we can remove while loop. I'm giving a rough idea about how to solve the problem. You can all do better than me for sure. We will do few optimizations, S1, S2, H. Yeah, inner loop can be removed. Yeah, so dumb way, we are doing dumb way. Okay. Are you with me here? This one, this is simple. And then what should we do? What else we should do? There is one more thing that is missing. We found a, when we find a triplet, what should we do? We should increase the number of triplets. Okay, awesome. GCC. See, the time it takes is pretty bad. We'll try to optimize it. Is there anything wrong we are doing? It is taking forever. It got stuck, huh? Huh. Oh, we have to keep increasing H, na? Okay, okay. So we will try for H, for a particular value of H. And then finally, what do? We do H plus plus. Line number 25. For a given value of H, we try 15 to 24. And then we, on line number 25, we are incrementing H. Is it okay? Between, when I run this program, my fan CPU started, fan went up because bad. Let's use /n. How many of you are with me on this program? Does it make sense? You can see that here we are printing the Pythagorean triplet 5, 12, 13, 12, 5, 13 two times. Triplets are repeated. How can we avoid this? So here we can make S2 is equal to S1. Does this make sense? Okay, because if you order it, then it should solve the problem, I hope. Okay, here we are making S2, we are starting S2 with S1. Or we can do. So it's, if you are looking at Pythagorean triplets, so you are, what we are doing is, this is your hypotenuse, H. We are trying different values of hypotenuse. Okay, hypotenuse try with 1, hypotenuse try with 2, hypotenuse 4, so on and so forth. And then focus on side S1. On side S1, we are trying, let's say, if hypotenuse is equal to I, then side S1, what is the, now side S1 we know for sure, since we are looking at integers, it has to be greater than 1. And what is the upper bound on S1? What is the upper bound on S1? The upper bound on S1 is H. Okay. And that's what we are doing here. That's what on line number 15, that's what we are doing. For a given hypotenuse, we are trying different values of S1. And then if you look at S2, so what happens S2? We can, without loss of generality, we can just think that S2 is always greater than S1, right? Yes or no? We can always think that S2 is greater than or equal to S1. Okay, perhaps. And also we know S2 has to be less than H. So these two conditions, so this is one first set of constraints, this is the second set of constraints. And we are iterating, no, we are trying out all possible S1s and S2 within this space. No, because S2 cannot be less than S1. We can assume all the time S2 is greater than or equal to S1. So, okay, let's run the program. H cannot be int. Why can't H be int? Okay, so now it makes sense. Are you all with me on this program? We didn't have any repetitions, right? Do we have repetitions? When we do this thing, we will not have repetitions. Oh, like without 3, 4, 5, and 6, 8, 10. No? That is going to be a bit tricky. You have to store and you have to check. Don't worry about them. Okay. We will count them as different. In order to check if it's the case or not, we need to store them and compare them. So it's so in order to give a different picture, so let's say for a given hypotenuse H, this picture will help you. This is S1, this is S2. So let's say if H is equal to 3, then the possible values for S2 are 1, 2, and 3, and the possible values for S1 are 1, 2, and 3. So if you see, this is 1, 1, 1, 2, these are all different side types. Are you with me here on this table? Do you understand this table? This table will help you in solving other problems. So now, in the first approach, what we did is we tried out all possibilities in this table. And check if they satisfy the constraint, that is if 1 square plus 1 square is equal to 3 square, 1 square plus 2 square is equal to 3 square, so on and so forth. But when we are doing this, we are doing double work. We are checking this and this again. We are checking this and this again. So instead, what we did is, we started with, the first way of iteration is you go like this. Okay. You go row by row and check. But then instead we did a clever thing. So what we did is, we went from here to here, we went here, and then again we came here, and then again we tried like this. Because we don't need to check, so we don't need to check diagonal line. Okay, so maybe. So, but anyway, we are just checking the lower triangular matrix, or we can even check the upper triangular matrix. Are you with me on this picture? That we can try either the lower triangular matrix or the upper triangular matrix. Okay. You're all good on these two problems. I hope those of you who have trouble. So those of you who didn't solve the challenge problem, I would like you to go ahead and solve it. Okay. Without trying to copy the code as it is, try to write, remember the logic and try to write on your own. It will still be a good exercise. And you can submit it because once our OJ will be open sometime today or tomorrow, so you should submit this problem also. Okay, I want all of you to submit all the problems, including challenge problems. Yeah, in this we are using upper triangular matrix. So I got 8, 6, 10. 6, 8, 10 is perhaps what we are looking for, Prakash. Maybe when we have a OJ, the TS will tell you, what is expected. No, everything will be kept. When the problem is kept on OJ, all the details like output format, everything will be kept. What is exactly expected, since the evaluation will be automatic, the expected output will be exactly kept. All right, I'll stop here. So we will again catch up on Thursday. So I will release the next problem set sometime tomorrow, or but yeah. Okay, then that's all for today. Thank you.